Found one more example hidden in the corner of my scratches, and so I should have made the last video shorter. I apologize, and combined that last example with this one. Also, I know that we only messed with the sine of 2u. We didn't play with the cosine or the tangent, so please work with some of those on your own, and we're going to do a couple of them right here, but come see me if you need help with any of that. So let's assume we're told that the cosine of u is negative 4/5, and this piece here tells us that u is in quadrant 2. So I know that before I'm even told what I'm trying to find, I should probably draw a picture of what that says. And if the cosine is the adjacent over the hypotenuse has to be positive, and so that means the negative 4 is the one that's negative there. Okay, here's my angle u. So maybe I'm asked, I've done a whole lot of sines, so let's find the cosine of 2u. And let's actually do this one 3 times, just so we can prove that we get the same thing no matter what. My cosine of 2u formula, there were 3 of them. We said we could take cosine squared u minus sine squared u if we wanted to. So the cosine of u, I was told what that is from the start, and that was negative 4/5, and I need to square that. If I need the sine of angle u, that's the opposite side over the hypotenuse, which is positive 3 over positive 5, and that's squared. So I have 16 minus 9 over 25, which is 7/25. That I can't write, but I can say 7/25. Remember, another option was that we could take 2 times the cosine squared of u minus 1. That's the same thing as cosine 2u. So we said cosine u, we were given, maybe I don't remember how to draw my triangle. I would have been okay here without having to draw it, only using the cosines to find cosine 2u. 4 over 5 squared is positive 16 over 25. I double it, I get 32 over 25 minus 25 over 25, which is 7 over 25. Okay, I'm not going to write the steps in there because this is fraction arithmetic. You should be able to get there. I could also take 1 minus 2 times sine squared u, and so from our triangle we said the sine of u is 3/5, and if we square that we get 9 over 25, and if we take 25 over 25 minus 18 over 25, we get 7 over 25. And again, we'll circle that one in red just to be different. So, and you most definitely don't think that you have to go through this 3 times and show they're the same. Pick whichever version of that double angle formula that you like best, depending on what you're given, what you've come up with on your triangle, whatever the case may be. If we're asked to find tangent of 2u, we said that's 2 times tangent u over 1 minus tangent squared u. Finding tangents with our sum and difference formula, with our double angle, our power reducing isn't so bad. Some of the half angle ones get kind of nasty again. But we're going to have a complex fraction here, and so that's something we need to not shy away from or skip over or avoid. If I look at my triangle up at the top, we see the fraction negative 3/4 is equal to the tangent of u. That's a negative sign hanging out in there. 1 minus, I'm going to square negative 3/4. On the top, 3/4 times 2 is 3/2. Keep the negative sign. Here on the bottom, when I square that negative 3/4, I'm going to get positive 9/16. Okay, I'm still subtracting it. That subtraction sign out in front doesn't go away just because the stuff inside was negative to begin with. Because again, when I square it, it really goes back to positive. So I have negative 3/2. 1 minus 9/16 is 16/16 minus 9/16, which is 7/16. And so when I put those pieces back together, I get negative 24 on top over 7 on the bottom. Alright, so that's my remaining example for the double angle section, or part of the section, and we're going to move on to power reducing in the next